Welcome everyone. We are discussing how to find maximum and minimum value using first derivative test. So application. So fx equals to x cube minus 6x square plus 9x minus 8. So consider problem number 1. Then f dash is 3x square minus 12x plus 9. So 3 common, x square minus 4x plus 3. So 3 into x minus 1, x minus 3. Factorizing. Now to find stationary point f dash x equals to 0 implies x minus 1, x minus 3 equals to 0. So x equals to 1. So we check maximum or minimum value at these two stationary points at x equals to 1 and 3. Now this is our real line, this is 1. Now for greater than 3 plus. Now this one for 3 plus, it is positive, it is positive. So f dash x is positive. For 3 plus, f dash x is positive. For 1 minus, less than 1, slightly less than 1. Suppose any value less than. So it will be negative and it will be negative. So it will take 0 also. So look, negative and negative. So it is positive. And in between 1 to 3, suppose 2, this is negative, this is positive. And this is negative. This is positive and this is negative. So you are getting negative. So look, at x equals to 1, at x equals to 1, dy by dx changes its sign from positive to negative. And at x equals to 3, dy by dx changes its sign from negative to positive. So we can conclude fx has maximum or minimum value at x equals to 1 and 3. At x equals to 1 and 3. Now, dy by dx at x equals to 1 plus 0, at 1 plus 0, 1 minus 0, suppose it is positive, and dy by dx at x equals to 1 plus 0 is negative. So dy by dx changes its sign from positive to negative. And look at the theory, from positive to negative at 1 minus and 1 plus. So fx has maximum value at x equals to 1. At x equals to 1. And in this case at 3, dy by dx at x equals to 3 minus 0, it is negative. And dy by dx at x equals to 3 plus 0, it is positive. So fx has minimum value at x equals to 3. Fx has minimum value at x equals to 3. So this is the rule how to find maximum and minimum value using first derivative test. But in board, we always use the second derivative test. So second derivative negative, maximum value, second derivative positive, minimum value. Now, next one. second one, fx equals to this. So what is f dash x? 5x to the power 4 minus 20x cubed plus 15x square. So 5x square is common. X square minus 4x plus 3. So 5x square common, and this is x minus 1, x minus 3. So what are the stationary point? Stationary point. X equals to 0, 1 and 3. Now draw a real line. This is 0, this is 1, this one is 3. Now for greater than 3, this is positive, this is positive, this is positive. So this one is positive. For less than 3, suppose it is 2.5. So it is positive, it is positive, it is negative. So this one is negative. For greater than 1, for greater than 1, but very small amount. Suppose x equals to 1.1. So this one is positive, this one is positive, and this one is negative. So total is negative. So total is negative. Greater than 1. So this is negative. And less than 1. Less than 1. Suppose 0.99. X equals to 0.99. X equals to 0.99. Sorry. So at x equals to 1.1. Greater than 1. 1.1. This is positive. This one is positive. So this is negative. So negative. So x equals to 0.99. Now this one is negative. This one is negative. So negative, negative, positive, and this is positive. So positive. So for less than 0, so it is always positive because it is square term. Less than 0. So this is negative. Less than 0. Suppose minus 1 minus 0.1. So this is negative, this is negative, 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 positive, this is positive. So look what we are getting. Now look at the theory. We see whether dy by dx changes its sign in the neighborhood of stationary point. At x equals to 0, dy by dx does not change its sign. So at x equals to 0, no maxima or minima. That is, x equals to 0 is a point of inflection. Now at dy by dx at x equals to 1 minus 0 is positive. Dy by dx at x equals to 1 plus 0 is negative. So positive to negative. So it has maximum value. Look at the theorem at x equals to 1. Maximum value. Now dy by dx plus 1, 3 minus 0, it is negative. Dy by dx 3 plus 0 is positive. So dy by dx changes its sign from negative to positive. So fx has minimum value at x equals to 3. So this to be noted from negative to positive. If you write this one from 3 plus 2, so condition will be changed. So this will be noted. If you have any confusion, so you get or negative. So 0 minus, it is negative. 0 minus, it is negative positive. So it has negative value and x equals to 3. So how to find maximum and minimum value using first derivative test. Now we take an example of trigonometric function. So fx equals to sine to the power 4x plus cos to the power 4x. So 0 less than x less than pi by 2. So you have to find first order derivative. Now what is f dash x? 4 sine cube x into cos x plus 4 cos cube x into minus sine x. So 4 cos x sine x is, this is sine square x minus cos square x. So this is 2 into sine 2x and this is minus cos 2x, because cos square x minus sine square x is cos 2x. So finally we are getting minus sine 4x. Minus sine 4x. So f dash x equals to 0 implies sine 4x equals to 0. So what is general solution? 4x equals to n pi. So x equals to n pi by 4. Now put n is integer. So n equals to 0. So x equals to 0, pi by 4, pi by 2, 2, 3 pi by 4 and so on. Now we take value of x in the specified interval. So what is the value? X equals to pi by 4. X equals to pi by 4. So at x equals to pi by 4, so f dash x at x equals to pi by 4 minus, and f dash x at x equals to pi by 4 plus, greater than pi by 4, greater than pi by 4, value greater than pi by 4. Now 4 pi, what is 4 pi? 4 pi is pi. So pi by 4 plus, so it is in third quadrant. So it is in third quadrant. In third quadrant sign is negative. Sign is negative and there is a minus. So this is positive. And 4x equals to pi. So 4x. So pi minus. At pi minus means in second quadrant. Sin 4x is positive and beginning at the negative, so you are getting negative. So f dash x changes its sign from negative to positive in the neighborhood of x equals to pi by 4. So we can say fx has extreme value at x equals to pi by 4. Now look at the nature. At less than value it is negative. At greater than value it is positive. So if you see the theory, so fx has minimum value at x equals to pi by 4. So this is how to find maximum and minimum value using first derivative test. I am saying repeatedly. So if it is problem of both, we always use second order derivative. Find second order derivative and put x equals to pi by 4, get part. Now today we are discussing how we can find extreme value of a function using first derivative test. That is why we are writing only first derivative and putting the values we get result. So we have discussed three problems: how to find first order derivative, how to find maximum and minimum value using first order derivative. So main theory is dy by dx changes sign, then it has maximum or minimum value. If dy by dx does not change its sign, then it has point of increase. So thank you.